So for this particular scan, we have this issue where there's this red lighting off on front row that looks very similar to our laser lighting. And it's okay down here, but really when we go here, it looks almost indistinguishable. So that's going to cause a problem when we use a color picker. So we'll try to do thresholding really carefully, and if that doesn't work, we'll have to try and mask this out because that's going to cause noise in our data that we don't want. Yeah, this is the noisy data. It has you can see these random points out here. That's from the light that we had at front row, and it makes it a little bit hard to tell how we are orienting this. And it looks like the color bounds are a little bit off. Not all of my good data is coming through. So it looks like we have a better threshold now. You can see this red line, and then there's a very faint red line you can barely see, but it's showing up right here. So that's great. But then this line that's from front row is not showing up. So that's good. So we're going to take these HSV values here, and we'll use that as our threshold for this data set.
So let's plot that.
In the data, this is actually a really nice scan. You can see this panel that's here is pictured right there. You can see the back of the bench and then how the front curves up. You can even, if we rotate it so you can see a little bit of the top of the bench. Can't see too much of that because it was kind of a flat surface, but you can see a little bit, and you'll notice that this curved part pokes out. So you can see there's like, this is the curve. This is like if we laid this on its face. There's this curve, and then there's this straight line, which is that post. This is just from the front data set, but I've spliced 5 different meshes together, but it isn't done perfectly yet, and there are some limitations to this. Oops. So if I rotate it, now there's like holes in it, which is a little bit, it looks like there will be some holes in the data, but I think I can also align it better. Looking at the bottom of the bench, and we're looking in the XZ plane. So here's the bottom and here's the back of the bench, and the back should be all parallel. So we're going to use dataset B, that's this one, as our reference because it's nice and parallel to the x-axis, and I like that. So then I made in MATLAB these rotation matrices that I can multiply angle rotations into my data set. So I'm going to go through and try and make all of these yellows kind of line up, and that will be step 1. So after rotating it, they still have these gaps, and part of that is that I still have to translate it, but I was hoping that they would somehow overlap a little bit when I rotated them. And I'm just not seeing that. And also the concerning part is that they don't line up in the vertical direction. They only line up at this weird angle. But my rotation matrices did effectively rotate, so these are all level now. There's something else going on with these points, and I need to figure out how to fix it. What I think is happening is that here's my camera's field of view, which the y-axis is vertical, the x-axis is horizontal, and the z-axis is the LiDAR depth measurement. And then here's my bench, and the bench, when I took my data, was somewhere in the XZ plane, but it was coming out of the XZ plane, but it was at an angle of some theta. And so then when my camera took the image, I think its field of view is still in this plane. So then when I took my data, I was getting these projections onto this field of view, which was introducing some error into my code because I didn't have anything to account for the fact that that was a projection in my alignment. So I did some trig, and this is like a 2D. If you took this and laid it down so you're looking at it from the top, here's theta. So if we call this our x prime, and we call this our x. And since this is we're doing projections of this onto this, so our right angle would be here. And then we know this distance because this is just our x and z. And then we want to find this distance. So what I did is I took all my points from out here, I moved them to the origin so that I could find, so their like distance was just like, if it was like from the minimum measurement, so it would be floating in space. I took this corner, aligned it here, and then I went to this and I said that x is equal to x prime cos theta, therefore x prime is equal to x over cosine theta. And I did the same thing for z, but for z it is z over sine theta. So that's what I did. It's not, there may be some error introduced by that, especially since y doesn't get changed in this scenario, but I think that will keep it from having these weird chopped off regions that I didn't see in my image so much, and I think it's just due to the fact that my camera was at an angle relative to the bench. So to kind of talk you through the code of how I got my final point cloud. First, I did the front of the bench, and here's just importing the data. Here's my distance offsets, mostly just in the x direction because I was moving the camera. Here's my angle offset that I needed to use, and that was with the reverse projection method I developed. And then here's me doing, actually I didn't end up using the rotation matrices, but I had originally been intending to. Here is the projection method being used, and here's the offsets being added, finishing the projection method, and then I concatenated that to all of my, to like the rest of them. Then down here, importing the side of the bench, processing it. This one I processed just using rotation matrices because it was easier. So you can see here I have like my rotation matrix equations, I have my angle offsets, and that was just to make it align with the frame of reference that my back of the bench already was in. And then we go to this one. So when we run it, yeah, this one just plots both of them together. So you see figure 1 plots just the bench and did all the rotations, put everything together. Figure 2 puts these data sets together and then puts them into the right orientation. And then here we put both of them together to get our final thing. Unfortunately, only half of my data turned out for this, but you can still tell that it's a bench because you can see this is like the side view and this is that back support. I colored it blue so that you could see it better. And then this, the rest of it is like, this is 5 data sets. This yellow and green is 5 data sets mashed together. And you can see this is like if the bench is laying on its back. So let's try and get it to where you can see the front view. Yeah, so then somewhere in there was a good view of the front of the bench. Yeah, like that. So you can see the 2 different legs, and then here's where the little notebook is, and then here's the curved back of the bench. So this data actually ended up turning out okay. It took a lot of manipulation to get to this point, but I think the end result is pretty good.